everyone, welcome to Serial. Today we are diving into one of the coolest topic in AI and machine learning, neural networks. So what is neural network? A neural network it is a model used in machine learning that is designed to work like a brain. Unlike human brain, it does not have physical or biological components, but it does some math with the input data, which may be images, text, video, or audio, and gives an output. This is not an easy task like a brain work, which involves a lot of training. Have you ever wondered how your phone recognizes your face or how Spotify recommends your favorite song? Guess what? Neural network are doing the heavy lifting behind the scenes. So let's break it down nice and simple using a real world example. Think of a neural network like a digital brain. It is made up of layers of nodes, or as we like to call them, neurons. And just like our brain processes information using neurons, an artificial neural network processes data to make decisions, prediction, or classification. Let's take a practical example. Say we want to build a neural network that can tell whether an image is a cat or a dog. Simple enough, right? Here how it all works. So the input layer is where the magic begins. It takes in the raw data. So here in our example, here each image might be converted into pixel values. So the numbers, they are the numbers representing colors. If it is a 28 into 28 pixel image, that's 784 input neurons. One for each pixel, that is 28 for one pixel. So the input layer's job is to just hold and pass on the data. It doesn't process anything. It just says, here you go, network, do your thing. Next, we have the hidden layers. And this is where the real computation happens. Each neuron in the hidden layer takes the input, multiplies it by a weight, adds a bias, and then passes it through an activation function. Think of it like this. Wait, how important is this input? Bias, a little push to help the neuron make a decision. So activation function is like a brain switch. Should this neuron fire or not? So let's simplify here. The input layer says pixel 1 is zero point 0.8 and pixel 2 is zero point 0.1. Then a hidden neuron might say, okay, zero point 0.8 into zero point 0.5 plus zero point 0.1 into zero point 0.9 plus bias. Let's activate. Each neuron learns patterns like, oh, a sharp ear shape. That might be a cat. And the fur, the textures, patterns. The neurons learns everything from the patterns. Weights and bias. This is like tuning the brain. Now let's talk about the heroes behind the scenes, weights and biases. Weights tell the network which features are important. Bias helps shift the decision boundary. During training, the neural network adjusts the weight and biases using something called backpropagation. It is a kind of learning from mistakes to improve the predictions. So early in training, the network might say, this furry thing is a dog, but after seeing more examples and adjusting the weight, it learns, wait, cats have pointy ears. Oh my bad. Alright, activation function, what are they? Simply put, they decide if a neuron should fire or stay silent. Here are the common ones. So the most common one used here is ReLU, which is rectified linear unit. So here is the output is output 0 if input is negative, otherwise just the input. It is fast and efficient. Then sigmoids, it squashes values between 0 and 1. It is good for probabilities. In our cat versus dog classifier, we might have two neurons in the output, one for cat and one for dog. If the final result is cat, it says it must be if it should have a value like 0.92. If it is a dog, it will have a value like 0.08. Boom, the network says the image is 92% likely to be a cat. The neural network learns by making predictions, checking how wrong it was, and adjusting its weight and biases accordingly. This process is called training and is often involves thousands of images, lot of mistakes, and eventually get great accuracy. It's just like how we learn by doing, failing, and adjusting. So let's recap. Neural networks have an input layer for raw data, hidden layer for thinking and pattern recognition, and output layer for decision, weights and biases for tuning, activation function for neuron decisions. And all of these work together to solve real world problems from recognizing faces to translating languages. If you found this helpful, hit that like button, subscribe for more, and drop a comment.